So on these problems, we're trying to find the volume of these figures like I showed you in class yesterday. In this particular one, it tells you what the base is. It says that the base is x squared plus y squared equals 4. If you don't remember, x squared plus y squared equals 4 is a circle, and the 4 is r squared. That means r is 2. So that's what this part is. This is the base. And then it tells you in the problem that you have things perpendicular to the x-axis and they are squares. So if it's perpendicular to the x-axis, it's coming down, so that's why this is the base of the square. And then this particular square is like coming up out at us. And there's another square maybe that you could draw at another place, like from here to here. That would be the base of it. And then the height would be different. So they're squares going all the way across from -2 to 2. Alright, so what you do, if you're trying to find the volume, is you're going to do the integral from left to right, however far the base goes. It starts at -2 and it goes to 2. And if you find the area of one of those squares, and you do the integral all the way across, the integral of the area will give you the volume. Just like on the other problems that we've done where you're rotating and you find the volume of one small little circle around it. That's why you do pi r squared. And then you do the integral, same process here. We just need to do -2 to 2 of the area of the cross section, and then you'll have your answer. So the area of the cross section would be whatever, in this case, the distance of the length of the side is squared, because it's a circle. So I'm just going to do length times width, which they're the same, so it's side squared. So here I just need to figure out what the length of the side is and then square it. Now, in order to find the length of the side, I need to know what equation that points on and what equation that points on. And see, x squared plus y squared equals 4 makes the whole circle, but if you solve for y, subtract your x squared, take the square root, and then do plus or minus. The positive part of the square root is this one up here, and the negative one is this one down here. So if I'm trying to find the distance of the length of that side, it's going to be square root of 4 minus x squared minus negative square root of 4 minus x squared. Or another way that you could do it is you could say it was 2 times the square root of 4 minus x squared, because the square root of 4 minus x squared is the distance from this point to the x-axis, so I know that 2 of them makes the base, and you can do it either way. I'm not going to work out the final answers here so that I can just give you an idea about how to do the problems. Alright, so we're going to continue with that same problem, so I'm not going to go to number 2 yet. And I'm going to draw that base again. But this time, let's say that instead of squares coming up, let's say that you have circles. So what happens is you have like a semicircle on top coming out, but then you have the circle on the bottom. So it's like with the base, like if the base is your hand, you have circles on top of your hand and you have circles on the bottom of your hand. So you have a circle going through your hand. And so that one is more like a sphere because it's not flat on the bottom. So similar kind of problem, you do -2 to 2, and then you do the area of whatever it is that you're doing the cross sections of. So everything was the same except the cross sections are circles. I know that the area of a circle is pi r squared. Since it's perpendicular to the x-axis, we do it in terms of x. There will be a time we do it in terms of y, but we'll talk about that later. So the radius is just the distance from here to here, which we found out previously that that was the square root of 4 minus x squared. And so that's pi r squared. Now, what if it said cross sections are semicircles? Well, the only thing that's going to change is that instead of pi r squared being the formula, I have to divide it by 2 because I don't have a circle, I just have half of a circle. The 1/2 could come on the outside if you'd rather it not stay right there. Okay, let's look at the next one. So this one is a triangular base. They're telling you that this is the base, the thing that makes the base. And so here is the y-axis, x equals 0, here's y equals 0, and here's the line. And so this time, they're telling us we've got circles. And they kind of drew up, but remember, part of the circle's above the base, and the other part is below the base. So I know that it's the integral from 0 to 6, because it's 0 to 6. The formula of the circle, pi r squared. So now I just need to find that distance. First thing, or the radius. So I'm going to solve this for y. I'm going to subtract x and then divide by 2. And so that's the equation. And what that'll give me is the distance from there to there. So what I'm going to have to do is I'm going to make that the distance, the radius, but then I have to divide it by 2. So all of that's in parentheses squared. Because the equation is the distance from the top to the bottom, but because I'm looking for the radius, I have to divide it by 2. Now, if we were looking at semicircles, the only thing that would change is that there's another divided by 2, but it's over the whole entire thing, and sometimes it's just easier to put a 1/2 on the outside. Alright, let's say we had squares. It'd be the same thing except there would be squares coming up. The thing about squares is that the base stays as a circle and the square just comes above the base. Nothing goes through the base except for circles. So the formula there is going to be 0 to 6 times the length of the side squared. So inside of the integral is always just the formula for the area of whatever kind of cross section that you're looking at. So the distance of the side, the length of the side, is from red dot to red dot. We already figured out that that distance was negative x plus 6 over 2. And then we square it because that's the length of the side. Okay, this problem is kind of a different problem. It's asking about equilateral triangles, and equilateral triangles are a little bit harder to think about. What I want you to do for your try problems, you're going to have 2 of them. Before I do the triangles, is I want you to do this problem using squares, and I want you to do this problem using semicircles. It would be the same picture as over here. The base would look like that triangle. And then if it were squares, there would be a length of a side and it'd be coming up and out. And it'd go all the way across. And then if it was circles, semicircles, you'd have that as the diameter and it'd come up. So there's your try problems for today. The triangles is hardest to figure out. The squares and the semicircles and circles, they're pretty basic. You kind of do the same thing every time. Triangles are less common. I hope you won't see any of those, but I need to show you a little bit about those. First thing I'm going to do is I'm going to solve this for y, because I know I'm going to need to at some point. I know that the formula is going to be the integral from 0 to 4 of 1/2 base times the height, because that's the formula of any triangle. Now, I'm going to out here to the side just talk about an equilateral triangle for just a minute. What I remember about equilateral triangles is that each of the angles are 60, because equilateral means all the sides are the same, so all the angles are the same. Now, I'm going to take off this 60 because I want to find the area of this triangle. And I know I'm going to need this height. The base is the distance from here to here, but the height is that little up and down part. So, I'm going to use right triangle trig a little bit here. I know that's 60, so I know that in that little triangle to the right that's 30. And there's a relationship between a 30, 60, 90 triangle. Across from 30 is 1, across from 60 is square root of 3, across from 90 is 2. Now, that means that whatever the base is actually the distance from here to here. The 1 is actually half of the base. So whatever the base is, I take half of it and multiply by square root of 3 to get the height. That's what that square root of 3 right there is. So, if I do it in terms of b's, maybe, this whole thing is the base, okay? But this is b over 2 because that's half the base. And then the height would be square root of 3 times whatever the half of the base is. So, this is the height. That's the base. And so when I do the formula, I would have 0 to 4, 1/2 times the base times the height. And this will always be the formula. But I think that understanding where it comes from kind of helps you a little bit. Now, I'm going to simplify a little bit because sometimes it would be simplified. Notice I can multiply the 1/2 and the 2 and the square root of 3. I can get square root of 3 over 4 and then b squared. It's okay if you want to leave it this way and then just substitute things in. But I usually like to simplify if you can because you'll see that way on multiple choice. So now, what I need to find is the length of the base. And that's where I look up here at this formula. Okay, the base is from there to there. That's just the formula. So that's going to be 0 to 4, square root of 3 over 4, 4 minus x squared dx. So on your try problems, that right there has to do with the length of that side right there. If it was a semicircle, the length of that side is the same, but you got to find the radius for the formula, so you'll have to divide that by 2. I know that this triangle one is really strange, but I needed to show it to you just in case it shows up. Here's my son. He made a snowball for you, and he's throwing it at you. You can make a math problem out of it. Can you find the volume of that snowball? Can you figure out the rate of change of the volume of that snowball? Hope you're having fun.